Hi there, this is the first video for Chapter 8, Part 1. The main topic of this unit is something called balancing equations. And the reason we balance equations has to do with this first law in the notes here, law of conservation of mass. Basically it says if we start with a certain number of atoms of some element, we need to end with the same number of atoms of that element. Atoms can't just disappear or appear out of nowhere. I'll let you read some of this other stuff. Um, we always write equations with the same format. Reactants are on the left side of the arrow, products are on the right side of the arrow. And next here, there are 7 elements that when they're alone, they actually won't be alone. They'll find another one of themselves and they'll pair up and form a diatomic molecule. Di meaning two, so diatomic meaning 2 atoms. And diatomic molecule means a molecule made up of 2 atoms. And there are 7 elements, and there's a trick to remembering them. If you look at this list, it's H, N, O, F, Cl, Br, and I. Those are the 7. The key to remembering these is remember the number 7. So here's a periodic table. If I look at number 7, which is N, and I go over to F and down and make a 7 shape, so NOFClBri, that's our first 6, and then the 7th one is hydrogen. So again, start at number 7 and make a 7 shape. NOFClBri. That gives you your first 6, and then the 7th one is hydrogen. So that's a little trick to remembering the diatomics. We will come back to that a little bit later. Here's just an example of a balanced equation and an unbalanced equation. I think the easiest way to see this, if you look at hydrogens. On the reactant side, the left side of the arrow, we have 4 hydrogens. On the product side, on the right side of the arrow, we have 2 hydrogens. We can see that that is unbalanced. On one side we have 4, on the other side we have 2. That's what we call unbalanced. It's not balanced. Now what we're going to do and what we're going to learn how to do in this unit is to put these numbers in front. These big numbers in front are called coefficients. And we're going to use those numbers, whatever numbers they need to be, it could be 2, 3, 4, whatever number it needs to be, to balance these equations. Now notice I put this 2 over here, and that big 2 out front is a multiplier, and it multiplies everything in this chemical, H2O. So instead of just having 2 H's, we have 2 times 2, we have 4 H's, which is what we have on the other side. So if we look at the balanced equation and just run through it real quick, we have 1 carbon on the left, we have 1 carbon on the right. Carbons are balanced. We have 4 hydrogens on the left. We have 4, I won't highlight just the H, there we go, 4 hydrogens on the right. If we look at oxygens, oxygen's a little trickier. We have 2 times 2, so that's 4 oxygens on the left. Here we have 2 oxygens plus another 2. Remember the 2 out front multiplies everything here. There's 1 oxygen, but you got to multiply it by 2, so that's 2 oxygens there. So 2 plus 2 is 4, and that's what we had over here, 2 times 2. We'll do some examples here. So these examples, we're going to go through these real quick. What I might do, I think, is, unfortunately I can't write on the PDF here, but I can write in this little grid down here. So what I'm going to do is I'm just going to put the numbers right below. But in reality, you should be putting the numbers in these blanks here. So I suppose I could rewrite it. Let's try that first. That's not too bad. So I have 2 H's here. on the left side of the arrow. I've only got one H on the right side of the arrow. So what I'm going to do is I'm going to put a 2 out in front of this. So now I have 2 H's and 2 H's. We're done with the H's. Check the chlorines. We got 2 chlorines and 2 chlorines. We're good. That is balanced. So you'd leave the 2 spots over here blank. Now they are blank, but in reality there's a 1 there, but this is one of those cases where we don't write the 1s. So you just leave those empty spaces there. Technically there are 1s there, but we don't write them. So blank blank 2 would be your answer for that first example. Next example. H2 plus N2 makes NH3. Now, one of the tricks that I will teach you, and these aren't rules, they're just tricks. They don't always work, but they will often work, is the first trick I'm going to teach you is the fact that odd numbers are kind of a pain in the butt. Even numbers are always going to be easier to work with. And if we look here, we have 2 H's on the left and we got 3 H's on the right. Well, I can make any odd number into an even number by multiplying by 2. So if I do that here, if I put a 2 out front, it kind of looks like a Z, but that's a 2. 2, if I put that 2 out front and it multiplies everything here, now I have 2 times 3, so I have 6 H's. Now instead of having an odd number of H's over here, I have an even number of H's, and even numbers are easier to work with. So I put that 2 there. Now I have 2 times 3 is 6 H's. Now to get 6 H's over here, what I'm going to do is put a 3. So I figured I got 6 on this side. What number can I put here that's going to multiply 2 to get 6? Well, 3 times 2 is 6. And so the H's are good. 6 H's here, 2 times 3, 6 H's there. 2 N's and 2 N's. We're done. Move on to the next one. P4, oops, where am I here? There we go. P4 plus O2 makes P2O5. I usually just start with the first element. How many phosphoruses do I have here? I got 4. Do I have 4 over here? Nope. So I got to fix that. If I put a 2 here, 2 times 2 is 4 phosphoruses. I got 4 phosphoruses, 4 phosphoruses. The phosphoruses are done. Move on to the next chemical. I got 2 oxygens over here. Over on the right side, I have 2 times 5, so I have 10 oxygens. And then I go back over to the other side and think about, okay, how can I get 10 over here? Well, if I think about what multiplies to 10, if I put a 5 here, 5 times 2 is 10 oxygens. 2 times 5 is 10 oxygens. The oxygens are balanced. 4 P's, 4 P's, the P's are balanced. So those were all fairly straightforward, but you can kind of see it's a kind of a back and forth, back and forth, back and forth kind of thing. The next one looks really complicated, but it actually isn't all that bad. See if I can fit this here. Al2SO4 in parentheses. 3 plus CaOH2. Oops, that's an arrow. AlOH3 plus CaSO4. Now it looks really complicated, but you may recognize some of these chemicals from the polyatomic ion sheet. SO4 is sulfate. OH minus is hydroxide. They're on that polyatomic ion sheet. So what I'm going to do is I'm not going to worry about anything in the parentheses here, and all I'm going to do is worry about the numbers outside the parentheses. Like over here, SO4 is inside the parentheses. I'm not going to worry about any of that. The only thing I'm worried about is what's outside here. And there's nothing written there, but technically there's a 1 there. So if I look at sulfates, I got 3 sulfates on the left. I only have 1 sulfate on this side. So I can fix that by putting a 3 here. So 3 sulfates and 3 sulfates. The sulfates are balanced. The other polyatomic here, I have OH, I got 2 of them. And here I got OH and I got 3 of them. Just like before, odd numbers are a pain in the butt, so I'm going to try putting a 2 there. 2 times 3 is 6 OHs. Well, I got 2 over here. What multiplies to 6? 2 times what equals 6? Well, 3. 3 times 2 is 6 H's. Now there's another hint that I wanted a 3 there, because if I look at calcium over here, I have a 3. And there's another hint that I wanted aluminum, a 2 in front of aluminum here, because if I look over here, I got 2 aluminums. So let's just double check here. 2 aluminums, 2 aluminums, 3 SO4s, 3 SO4s, 3 calciums, 3 calciums, 3 times 2, 6 OHs, 2 times 3, 6 OHs. It is all balanced. Okay, let's do one more example. I think I got time for one more. Actually, that one's kind of a tricky one. So what I'm going to do is I'm going to pause here, end this video, and we'll do another video, and I will finish all the rest of these examples. There's a couple more tricks. I told you about the putting a 2 in front of odd numbers trick. There's a couple other tricks that I think are very helpful, so we will cover those at the beginning of the next video.